Hi all, welcome back to statistics. Today we're going to cover how to estimate the unstandardized regression equation from a scatterplot and how to calculate the standardized and the unstandardized regression equation from raw data. There is the class exercise with this lecture, so make sure you're looking to Blackboard under the class exercise folder for class exercise 16, calculating the regression equation from raw data. Before we start the lecture, let's review on some material that we covered the previous weeks. So, in the last lecture, we covered the C-equal line and the regression line. We mentioned that the regression line, it's always going to go through the point of averages, and the slope for the standardized regression equation is going to be equal to beta, which is equal to R. R being the correlation between the predictor and the criterion. We also mentioned that the positive C-equal line and the negative C-equal line also go through the point of averages. So both the regression line and the C-equal lines go through the point of averages. We talked about the slope of the positive C-equal line. So the standardized slope is always going to be equal to 1. And the standardized slope of the negative C-equal line is going to be equal to -1. We also mentioned that the C-equal line is almost always steeper than the regression line. We also mentioned that a regression line with a positive slope gets closer and closer to the positive C-equal line as R gets closer to 1. So when R is equal to 1, the regression line and the positive C-equal line are going to have the same slope. So when R equals to 1, the regression line and the positive C-equal line are identical. So let's use the scatterplot as a demonstration. So we have an x and a y variable. There is no correlation between this x and y variable. So we can see that the regression line, which is the blue line, is completely flat. And then the red line is the positive C-equal line. So let's see what happens as we increase the correlation between x and y. So as we increase the correlation coefficient, the regression line starts getting closer and closer and closer to the positive C-equal line. Once we have a perfect correlation, the regression line overlaps the positive C-equal line. So the regression line is equal to the positive C-equal line when we have a perfect correlation. What about a regression with a negative slope? Well, a regression with a negative slope also gets closer and closer to the negative C-equal line as R gets closer to -1. So when R equals to -1, the regression line and the negative C-equal line are identical. So let's use the scatterplot as a demonstration. As we can see, as we increase the strength of the correlation coefficient, the regression line gets closer and closer and closer to the negative C-equal line. Once we reach a correlation coefficient of -1, the regression line pretty much overlaps the negative C-equal line. We also talked about how to calculate the unstandardized equation of the regression line. We mentioned that in order to calculate the regression equation precisely, you need the mean of y the standard deviation of y, the mean of x, the standard deviation of x, and the correlation coefficient between x and y. So we used the similar steps that we used about 4 weeks ago when we were calculating the slope and the intercept of 2 points that fall within the line. However, we're not going to use the first step. We're going to skip the first step and we're going to go into the second step. So in our second step, we're going to use a special formula. Once we have the slope, then we use the same steps. We calculate the intercept. So we need a point, and we already have that information already. We have the means, and remember that the regression line always goes through the point of averages. So this is your point of averages. So we have a point in the line, and we have a slope. So once we calculate the intercept, then we just plug in our values to their general equation of a line. So we have a slope, we have an intercept, and we plug in those values. So let's go over the steps again. So the steps for calculating the standardized regression equation. First, you're going to need a slope. You're going to use this formula to find the slope. Once you find the slope, then you're going to need to find the intercept. So you're going to need a point. That point is going to be your point of averages. And then from there, you plug in you solve for your intercept. Once you solve for your intercept, then you plug in your values into your general equation of a line. We also talked about how or why this formula works. And we give an example of an ant walking on the regression line. So if the ant goes sideways, one standard deviation of x is going to go up one standard deviation of y. So if the ant moves along the regression line, it's going to move one standard deviation of x across, and then r standard deviations of y, or in this case 0.50 standard deviations of y. So this idea applies to other correlations as well. So if the correlation is 0.80, it's still going to go one standard deviation of x across, and then r standard deviations up, or 0.80 standard deviations of y up. So one standard deviation of x across, and 0.80 standard deviations of y. So the slope, it's equal to 0.80 times SD of y divided by SD of x. So we also talked about prediction error. We mentioned that prediction error is how much prediction is off. So it's the difference between the predicted value and the actual value. We also talked about some notation. So y hat 1, it's the predicted value of y for individual number 1. y1 is the actual value of individual number 1. And E1, it's the difference between the actual value of individual number 1 minus individual number 2. So we can pretty much do this for every single individual that we have in our data set. So we can have up to 100. So we would have E100 equals to Y 100 minus Y hat 100. Okay. So we can do that for every single person in our data set. So we talked about root mean square error of the prediction, which is the typical difference between the observed value of Y and the predicted value of Y. We talked about how to calculate RMS error, and there's two ways to calculate RMS error. The first way is the long way. In the example that we gave last class, we had 700 participants in our data set. And basically the long way would be to calculate all 700 errors. So we would find the error for every single individual. And then we would calculate the root mean square of those 700 errors. So root mean square, it's squaring all the errors, adding up all the errors, finding their mean, and then calculating the square root of those of that mean. So depending on the size of your data set, the long way might take a few minutes or it might take hours to calculate. In the example that we gave in class, we had 700 individuals in that data set. So imagine calculating the error for 700 individuals, squaring that error, finding an average of that error, and then finding the square root of that error for 700 individuals. So it's going to take a while. Now, there's a short way for how to calculate RMS error. So there's a formula for that. And the formula is this. So the formula for RMS error is equal to the square root of 1 minus R squared times SDOY. Now, for class, any quizzes, exams, you guys should be using the short way. However, it's important that you understand the concepts of the long way. Okay, so use the short way to calculate RMS error, but still understand how RMS error works. Okay, so RMS error is just an average error. It's very similar to the standard deviation, where the standard deviation is the typical distance from the mean. So RMS is just a typical error from the actual value of Y. So let's talk about the new material. So today we're going to talk about how to sketch the regression line on the scatterplot and estimate the unstandardized regression equation. So let's take this example. So we have IQ on the x-axis and we have GPA on the y-axis. So the scatterplot is showing the relationship of IQ with GPA in a group of several hundred students. Each dot represents one student. Okay, suppose somebody hands you this scatterplot and says, well, what do you think the standardized regression equation is for predicting GPA from IQ? What would be the easy way to do this? So one thing we can do is we can divide the scatterplot into vertical strips and sketch the conditional means. So we take our scatterplot and then we divide it into sections. Once we have the sections, then we find the conditional means. So remember, this is just estimating. We're We're just gauging where the conditional mean would be based on the points that we have on each interval. So the conditional mean for this is somewhere around here for this group of individuals. Okay, so you do the same thing for every group of individuals. Okay, and you have your conditional means. Now we can sketch the regression line that fits through the conditional means. Now remember, the regression line always tries to go through the conditional means. And now it's not going to do it for every single conditional mean, but it's going to go through most of them. So once we sketch our regression line, what we can do is choose 2 points on the regression line and estimate the unstandardized coordinates. Okay, and then we're going to use these points to calculate the unstandardized equation of the line. So first thing we need to do is to find the slope. So we have to calculate the difference between the y's, which is going to be the rise, and then we have to calculate the run, which is the difference between the x values. So our slope, it's equal to 0.011. Then we have to find the intercept. So we need another point in the line. We already used 2 points, so we can take any of those 2 points. Okay, so we're going to use 70 and 250 for this example. And from here, we calculate our intercept. So we plug in our data. So we have our slope. We have our x value and our y value. So we plug in those values. So y is going to be 250. The slope is going to be 0.011. X is going to be 70. Okay, and then from here we solve for the intercept. Okay, so 0.011 times 70, it's 0.77. And we have to move 0.77 to the other side. So we subtract it from this side. So we subtract to the other side as well. So we end up with 1.73. So the intercept, it's equal to 1.73. So now that we have our slope and our intercept, then we just plug in the values into the general equation of a line. So we have a slope and we have an intercept, and we just plug in the values. And we have the unstandardized regression equation. Now you need to understand that this is just an estimate. So it's only approximately correct. So again, if you want to estimate the equation of a line, you divide the scatterplot in strips and sketch conditional means. You sketch the regression line. You choose 2 points on the line and estimate their coordinates. And you use those points to calculate the slope and the intercept of the line. Okay, so now let's talk about how to calculate the standardized and unstandardized regression equation from raw data. The raw data is the actual data of the x and the y variable. So imagine this is an x variable and this is the y variable. Okay, so this would be the raw data for x and y. Okay. So in order to calculate the regression equation, from raw data, you need to follow 3 steps. So first you need to calculate 5 basic statistics, which are going to be the mean of x, the mean of y, the standard deviation of x, the standard deviation of y, and the correlation between x and y. So you guys have done this before. It's not something new. You guys have been calculating the means, standard deviations, and the correlation coefficient for the past months. Okay, so you guys know how to do this. So you've seen this table before. Okay. So once you fill out the table, it should look something like this, where you have your means and mean standard deviations, and then you have your correlation coefficient. Okay. So once you have those 5 statistics, then you have to write your standardized regression equation. Now, the standardized regression equation is very simple. Remember that the standardized regression equation, it's always going to be C of y equals to R times C of x. So once you calculate your 5 statistics, one of them it's the correlation between x and y. So one of them it's R. All you have to do is just plug in that R value, and you have your standardized regression equation. If your correlation coefficient is 0.50, then that's what you're going to put for R, 0.50. Now if you calculated 0.80 for your correlation coefficient, then you're going to put 0.80 for R. So that's your standardized regression equation. Okay, so how do you calculate the unstandardized regression equation? Well, once you find the 5 basic statistics, from there it's the same steps that you guys have done before. So first thing you're going to do is you're going to find your slope. And remember, you're going to use this formula. R times ST of y divided by ST of x. Once you use this formula, then you need to find your intercept. So you need a slope and you need the point of averages. Okay. At this point you have calculated the point of averages from the raw data. So all you have to do is just plug in those values and then solve for the intercept. Once you solve for the intercept, then you plug in your values into the general linear formula for a line. Okay, let's use this data set as an example. So remember, the first step is to calculate the 5 basic statistics. The mean of x, mean of y, the standard deviation of x, and the standard deviation of y. Once you have those 4 statistics, then you calculate the correlation coefficient. So remember, the correlation coefficient is the average cross product of the z-scores. So once you find the z-scores, you're going to multiply those, you're going to add those up, and then find an average, and that's going to be your correlation coefficient. So once you do that, okay, so first step is calculate your 5 basic statistics. So we have our means, and we have our correlation coefficient. From here, then you're going to write your standardized regression equation. So we pull out our statistics, and now we're going to write our standardized. So now we're going to write the standardized regression equation. So remember that your standardized regression equation is always going to be C of y equals to R times C of x. So you already calculated the R component, or the correlation coefficient. So all you have to do is take that value and plug it in into your regression equation, your standardized regression equation. So you plug in the value and you're done for your standardized regression equation. Now we need to calculate the unstandardized regression equation. So the first step is to find the slope. And again, to find the slope, you need this formula, which is going to be r times sd of y divided by sd of x. So you're going to take your formula, and then you're going to plug in the values. So these are the values that we calculated, and all I'm going to do is just plug them in. And then you solve for your slope. So once you solve for your slope, then you need to find the intercept by using the slope and the point of averages. So we know the slope and we know the point of averages. So remember, the point of averages is the mean of x and the mean of y, which is these two values right here. Okay, and then we solve for the intercept, so we have to plug in our values. So we plug in 13 into x, and then 12 into y, and then the slope. From here, we solve for the intercept, and you should have an intercept of 8.87. And then from here, you just plug in the values into your general equation of a line. And now you have the unstandardized regression equation. Now this is exactly correct. So this is not an estimate, this is the actual regression equation of this data set. Okay, at this point, go ahead and complete exercise 16. Once you're done completing exercise 16, then come back to the video and continue with the lecture. So once you complete the table for exercise 16, these are the values you should have had for the mean and your correlation coefficient. So you take your 5 basic statistics and you follow these 3 steps that we talked about. So the first one was just calculating the 5 statistics. Okay, the second step is to write the standardized regression equation. And again, remember the standardized regression equation, it's always going to be C of y equals to R times C of x. In this case, R was 0.25, so that's what we plug in into the R value. From there, we calculate the unstandardized regression equation. So we need to find the slope. We use our formula. We plug in our statistics. We solve for the slope, and then from here we solve for the intercept. So to solve for the intercept, we need the slope and the point of averages. Okay, so we already calculated that. So remember, point of averages is just the mean of x and the mean of y. So we plug in those values and we solve for the intercept. So once you have your slope and the intercept, then you plug in your values to the general equation of a line, and then it should look like this. So that's your unstandardized regression equation. Okay, so in summary, if you only have a scatter plot, then what you can do is divide the scatter plot into sections, estimate the conditional means, draw a regression line through those conditional means, and then choose 2 points in the regression line to use as your as your coordinates in order to find the slope, the intercept, and then plug in those into the general equation of a line. Now, if you have raw data, then you need to calculate those 5 basic statistics. So the mean of x, mean of y, standard deviation of x, standard deviation of y, and the correlation coefficient between x and y. Once you have your statistics, you use your formula of slope. So r times st of y divided by st of x. Once you have your slope, you find your intercept. So you use your point of averages and your slope for that. Once you find your intercept and your slope, then you just plug in the values to your general equation of a line. That's for the unstandardized regression equation. For the standardized regression equation, it's very simple. You just calculate the 5 statistics. One of them is going to be R. You take your R value and then you plug it into your standardized regression equation. So remember the standardized regression equation, it's always going to be C of y equals to R times C of x. Okay?